Alright, here's another fun-filled video talking about precalculus and trig. Here we're going to look specifically at what it means to find an angle value if your quadrant has been restricted. So what this means is that you're going to be given a function value, then you're going to be given the interval of restriction, and what you have to do is you have to try and find the angle measure that terminal side lies in. So there's a couple things that we have to remember. First thing that you need to remember is that we have to evaluate by solving the function for that theta value. So that's the first thing. So here, like in this first example, I have the secant of theta is equal to the negative 1.0485. So in order to start even figuring out what the theta has to be, you would have to solve for the missing variable, which in this case means solving for theta. So for example, we would have that theta is going to be the secant to the negative first power of negative 1.0485. Okay. Now with this, obviously we can't have, we don't have a button, say, on our calculator that is secant, or at least most of them don't. So for example, if you look at this one here, notice the only buttons I have are sine, cosine, and tangent. And so I have to know how we can rewrite this to get what we want using our calculator. And we have to go back to using our original rules, which say when you have the inverse secant, you would solve it by saying that we're going to use the cosine, inverse cosine, but then what we enter into our calculator is 1 divided by the value, 0.485. So instead, this is what we would input, and this should give you your degree. Now, whenever we get started, the first thing that we always need to do, especially with some of these problems, is we always want to double check your mode and that you are in the proper type, whether it's radians or degrees, and in this case we're looking for degrees, so we're good. So here we're going to put this directly into our calculator. So we have second cosine, which is going to give us that cosine to the negative first. Here, let me put it down here so you can see a little better. And then we're going to simply type 1 divided by, and then we're going to go negative 1.0485, close your parenthesis, and hit enter. So this right here is going to be your degree. So in this case, we are looking at 162.51 degrees. Now with this, once you figure out a degree measure, there is one other step that you have to do for these problems, which is that your second thing is you have to check to be sure the degree measure is in the restricted quadrant. So in this case, I have 162. So if you look in this first one, I was restricting the quadrant between 90 and 180. So what this means is that we are restricted specifically to quadrant 2. So this is where we're restricted with quadrant 2. If you look at 162.5, that should fall in quadrant 2. Therefore, this degree measure is exactly where it's supposed to be. Okay. Now let's look at a second example here, because this one, the second example, is a very interesting one. And what we're going to find out is that the degree measure might not actually fall where it's supposed to. So then you need to look at how exactly are we going to make it work. So first and foremost, we need to solve. So in this case, we would end up getting that theta was equal to the inverse sine of negative 0.4313. So just like before, you're going to pull out your calculator. So we're going to pull this out here. And we're going to go ahead and find our inverse sign. So you're going to go second sign, and then you're going to have negative 0.4313 and close it. Hit enter. And here we get that that degree is going to be negative 25.6. So here we're going to find that this theta here is negative 25.6. So once we figure out what our theta is, we need to double check. And so here, this is where to double check. A lot of times you're going to want to draw your coordinate plane. And so in this case, what we need to remember is, say this is 0 and this was 360. And here what we're actually doing is we are going negative 25.6. So when we go the negative 25, what this actually means is that we're telling you that it's going to be down here. And so this angle right here is going to be your theta, negative 25.6. However, we got a problem. Our restriction says we're supposed to be between 180 to 270. So this is 180 over here, this is 270 downstairs, which means this is supposed to be my third quadrant. And if you look, my angle is currently in my fourth quadrant. Therefore, we have to be able to move the angle. So what we do is we mirror the angle into the correct restricted quadrant. So mirroring, it simply says you're going to take this and you're going to sandwich it, or basically mirror it over. So if I were to fold along my quadrant line, whatever you had marked here would show up on the other side. That's the mirror. And so what happens here is that we end up getting our angle to show up on this side, okay, which means this piece right here becomes a reference angle. So this becomes your reference, which is your theta value, okay. Now we actually have to find the whole thing. So we need to know what actually was the whole angle measure. So let's call this beta. So to find beta, we need to take 180 degrees and add your reference angle. So in order to actually find our angle here, we're going to do that beta is going to be 180 plus my theta value, which was 25.6. And this should give you the whole angle as if we rotated it in the positive direction. And so here what you end up getting is 205.6 degrees. So in this case, we would have your angle being 205.6 degrees. And that gives you the degree measure that falls in the correct quadrant. Now, this can be a little bit of a challenging concept. So I did create another example that I wanted to go ahead and just show you, just to make sure that we're all on the same page. So let's say we were given that the cosine of my angle is 0.6561, and we are told that the interval is restricted to 270/360. Okay, so we need to do the same thing. We have to find your theta angle. So the first thing that we of course want to do is we have to solve for theta. So here we would end up getting that theta is going to be the inverse cosine of 0.6561. So we're going to input that in our calculator here. So here's our calculator. And we're going to go second cosine of 0.6561, close it, and hit enter. And we get 48.99, so we would round that up to roughly 49 degrees. So we would say here that your theta is going to be about 49 degrees. So the next thing that we have to do is we have to look at, okay, so you are going to essentially graph the degree. Okay, so graphing the degree essentially means we're going to create our coordinate plane here. And my theta is 49 degrees. So we know 49 degrees falls in that first quadrant, so it would kind of be right about here. And so this is my theta at 49 degrees. Now, the thing that we notice is that my interval is supposed to be restricted. So I am supposed to use 270 to 360. This means that I am restricted to quadrant 4. Well, if we look at my graph, I'm in quadrant 1. I'm not down in quadrant 4. So I have to be able to move it. So to do that says I have to mirror the theta into the restricted quadrant. So I was up here at 1. To mirror it says I'm going to essentially fold my page down. So I'm going to go from 1 down to 4. So essentially my degree is going to come down here. Now again, just like before, this right here now becomes a reference angle. So in order to actually find my degree, says I have to reverse how to calculate a reference angle. So in this case, if you remember, the reference angle in quadrant 4 was calculated by taking 360 and subtracting away whatever your angle was. So when we're talking about our reference angle, we are talking about 360 minus that theta value. Okay, and that's going to give you your reference piece. Well, in this case, I have the reference piece, but what I don't have is the full angle. So here, I have my reference. So I actually have that 49 was equal to 360 minus the value I'm looking for. So I have to solve. Essentially, we end up getting that the theta we want is going to be 360 minus my 49, which is actually going to give us 311 degrees. Now, since this 311 here falls inside my quadrant 4, I have solved my problem. Okay? Alright, now another way that we see some of these problems is written as follows, where it says use the given information about each angle to evaluate the expression. And we're telling you that the cosine of an angle is the square root of 12 over 4, and that the tangent of the angle is negative, and you need to determine the angle and what the tangent of the angle is. So the way you get started is we get started by drawing our coordinate plane. So we have to look at the information we've been told. So the information that we've been told is that we have the cosine of your angle, which we need to remember that cosine is equal to adjacent over hypotenuse. And we're saying that this is equal to square root of 12 over 4. The other thing that we know is that the tangent is negative. So that being the case says we also need to remember all students take calculus. So in terms of the tangent being negative, we know that it can exist here in my second quadrant or here in my fourth quadrant. Okay. Now with that, if you look, the adjacent piece is positive. So I would put my angle down here in my quadrant, because if this was my angle and I'm telling you that the cosine of that gives you the square root of 12, that says that the adjacent side is 12 and my hypotenuse is 4, and the piece that's missing is my y value. And so here I need to solve for it, and I do that using Pythagorean's theorem. So I again know a squared plus b squared is equal to c squared. So I need to put in the information I have. So I've got the square root of 12 squared plus b squared equals 4 squared. This gives me 12 plus b squared, which equals 16. So b squared is equal to 4, which means my b is equal to 2. So here, this is actually going to be negative 2. So now with that, I have to be able to determine my degree, and I have to be able to find the tangent. So the first place I would start is I would start with my tangent. So I know the tangent of my angle is going to be opposite over adjacent. So this is going to be negative 2 over the square root of 12. And I have to rationalize. So this is going to end up being negative 2 square roots of 12 all over 12. Well, in this case, the first thing that I would do is I would reduce my values down. So with that, I know 2 and 12 reduce. This becomes a 1. The bottom becomes 6. So this is going to give me negative square roots of 12 all over 6. But then my square root of 12 can reduce, and it actually can reduce down to 2 square roots of 3. So this is going to be negative 2 square roots of 3 all over 6. And again, my 2 and 6 can reduce. This is 1, this is 3. So this is going to end up being negative square root of 3 over 3. So once again, my tangent of theta is going to be negative square roots of 3 over 3. So this was the first piece I was looking for. And then the second piece I'm looking for is your degree level. Well, one of the things that we know about your tangent being the square root of 3 over 3 is that it has it works along with, sorry, I lost my train of thought here for a second. So when we're working with that tangent, being that it's the square root of 3 over 3, one of the things that that tells you is that it falls into one of our special triangles. And so with that, we know that we actually have the 30-degree triangle. So in this case, we know that our theta here is actually 30 degrees. Well, the other piece about it is that not only is it 30, but we have to look at the angle in which that it occurs in. And since I'm down here in this fourth quadrant, one of the things I know is that my theta has to be negative, and that in order to get this negative angle here, we have to take that fourth quadrant into account. So here we know the tangent is going to be negative square root 3 over 3, and we know that my angle is going to be negative 30 degrees. So if you have any questions about any of the quadrant restrictions, please be sure to let me know. If you feel like you need to see or want to see some additional examples to try and help explain the concepts, let me know that too, and I would be more than happy to work some out. Otherwise, remember to be creative. Always draw those triangles even if you don't feel like you need it. And I will see you next time.